Hi everyone, welcome to the another session. I am your Dr. B. Shekhar working as a associate professor in Marri Laxman Reddy Institute of Technology and Management. Last class we have discussed about the energy sources or fuel and combustion. Some of the notes, textbooks they are written as a energy sources, and some of the books they are mentioning as a fuel and combustion. The both names are same related to the one topic. Now we will see about the energy sources. Last topic we are covered about the solid fuels. To explain the solid fuels, we took coal as a best example to explain about the solid fuels. On that, the classification of solid fuels and the analysis of coal. Based on the proximate analysis and ultimate analysis, we are seeing that one. And after that, the next topic today, I want to discuss about the liquid fuels. Today, I want to discuss about the liquid fuels. To explain the liquid fuels, the best example for the liquid fuel is petroleum. Petroleum is one of the primary fuel to explain the liquid fuels. It is a best example. Petroleum is one of the primary liquid. If we purified that primary fuel, we are getting our secondary fuels like our desired products like petrol, diesel, kerosene, and naphthalene, etc. etc. Actually, what is mean by the petroleum? Petroleum is a primary fuel, and the petroleum word is came from the Latin. The petra means rock or stone, oleum means oil. That was given here. The petra is nothing but the rock or stone. The oleum means oil. So the petroleum also called as a rock oil. The petroleum also called as a rock oil. This petroleum is we are extracting. The petroleum is we are extracting from the earth crust. The petroleum is when we are extracting, that is not in the pure form. It is combination of multiple minerals and mud particles and etc. etc. To separate the impurities from the petroleum, we are applying some techniques or process. And that the first one here we will see about the industrial refinery process of the crude oil. It is one of the oldest and very effective method to get our desired product from the petroleum. This refinery process of crude oil, the refinery process of crude oil, it will involve in a three steps. It will involve in a three steps. In first steps, we are removing the impurities from the crude oil. We are removing the impurities from the crude oil. The second step is removal of water. The removal of water from the crude oil, it is also called as a Cattrall process. The third step is fractional distillation setup. The third step is fractional distillation process or setup. In the first step, to removal of impurities. When we are talking about the petrol, the main impurity is sulfur. To remove that sulfur from the petroleum, we are adding copper oxide to that petroleum. This copper oxide is reacting with that sulfur and we are getting a PPT like copper sulfate. The PPT, it is settled down at the bottom of the petroleum. So we are removing that one. And the second step is when we are extracting the petroleum from the earth crust, it is combination of mixture of water also. To remove that water, that is also essential for the get good calorific value. So for that, the removal of water, we are also removing that process we called as a Cattrall process. To remove that water, what we are doing, the petroleum, the sulfur removed petroleum is we are passing through a chamber. The chamber contain highly charged electrodes. The highly charged electrodes, they are separating water as a water droplets and the water is removed from the crude oil. The removal of impurities and removal of crude oil we called as a pre-treatment method. So we have done some pre-treatment before extracting. So after that, the main, that is fractional distillation setup. When we are doing the fractional distillation setup, according to their boiling point, they are condensing and we are getting some fractions. So that is based on their chemical composition, carbon percentage, and temperature, what kind of the product we are getting, this table explaining to us. So this same table here I am explaining with a neat labeled diagram. So what is our third step? That is nothing but a fractional distillation setup. In this fractional distillation setup, you can see it is look like a steel or iron cylinder. In this steel or iron cylinder, we have the so many outlets we have. So many outlets we have, one inlet we have here. With help of this inlet, we are inserting our pre-treated crude oil, and here also in this chamber we are maintaining 300 degrees centigrade also. When we are applying this much of heat in the bottom of this cylinder, the petroleum is converting into the vapors, and that vapors, they are trying to escape from the cylinder. So if you see the cylinder containing so many trays, this we called as a simply trays or columns. The columns, they are covered a lid. This lid will lift by the cracks of the petroleum, means vapor of the petroleum, and they are condensing based on their boiling points. If you see from bottom to top, the temperature is gradually decreasing. Here we are mentioned the temperature is 50, here we are mentioning 120, and here we are maintaining nearly 200, 250, and here 300 to 350. Means at top of this cylinder, the carbon percentage is C1 to C4 carbon percentage, and nearly temperature is 30 to 50 degrees centigrade. The uncondensed gases we are extracting here, we are collecting here. After that, nearly here 80 to 120 degrees centigrade, here the carbon percentage is C5 to C10, our desired product, that is our petrol or gasoline. The petrol or gasoline, both are same words. And after that, the carbon percentage is C14 to C20. Some of the books also they are mentioning the C10 to C14 also, that is nothing but our diesel. Like that, from top to bottom, the temperature is increasing and the carbon percentage is also increasing based on their boiling point. They are condensing and we are getting our desired products, that is nothing but the petrol, diesel, kerosene, and naphthalene, ethers, the solvents, etc. etc. Here we are getting our petrol or gasoline, here we are getting the kerosene, and here we are getting the diesel, and it is a fuel containing heavy oil. The heavy oil also we are getting here. This is about the fractional distillation setup. That means they are fractionating, they are dividing, and they are condensing based on their boiling points. It is about the fractional distillation setup. We are the table, the same table I am given here for easily understanding. I hope you understand about this first step. The second process also we have, that is preparation of petrol or gasoline by the synthetic method. Synthetic method also we have here. That process we called as a Fischer-Tropsch process. The synthetic petrol process we called as a Fischer-Tropsch process. The Fischer and Tropsch, they are the two scientists. The Fischer and Tropsch, they are two scientists. They are invented this method or process. So to recognize that scientist, we are given that name to this process like Fischer-Tropsch process. In this Fischer-Tropsch process, what is the difference between the industrial refinery process and Fischer-Tropsch? In the Fischer-Tropsch process, we are not using the crude oil. Crude oil we are not using here. Instead of this crude oil, what we are using? We are using the water gas or syngas we are using. What we are using? We are using the water gas or syngas. So what is the mean by the water gas or syngas? This water gas or syngas we are getting from the red hot coke. When the red hot coke, we are sprinkling the water on that red hot coke. On the time the steam is coming out, the steam is we called as a water gas or syngas. From this water gas or syngas, we are synthesizing our petrol or diesel. How it will happen? To easily understand this diagram will help us about the Fischer-Tropsch process. So here also what we are doing? We are producing the water gas, and the water gas we are inserting here. The water gas is also mixing with excess of the hydrogen. The water gas is also mixing with the excess of the hydrogen, and they are moving towards this chamber, the first chamber. In this first chamber and in this second chamber, we call the purification chambers. In these purification chambers, we are using the chemical Fe2O3 and along with the sodium carbonate CaNa2CO3. By using these two chemicals, we are removing the sulfur from the water gas or syngas. To remove the sulfur from the water gas, these two chemicals we are using in purification chamber. Pre-purified water gas is moving towards the compressor. In the compressor, the gas is compressing, and after that it is passing towards the our main chamber we called as a catalyst chamber or catalytical chamber. In this catalyst chamber or catalytical chamber, we are in this net type shape. It is nothing but our catalyst. But this catalyst is combination of four chemicals, four other products. That is nothing but the cobalt, thoria, magnesia, and kieselguhr. The catalyst is combination of these four chemicals, and they are also, if you want, you can remember this one. The cobalt, it is a 100 parts. Thoria, it is a 5 parts. The magnesia, it is a 8 parts, and kieselguhr is a 200 parts. This much of using the ratio they are prepared about this catalyst, and with the help of this catalyst, the water gas is undergoing some chemical reactions, and we are getting alkanes and alkenes. Alkanes and alkenes. Alkanes and alkenes we are getting. The alkanes and alkenes, they are moving towards the next chamber, that is nothing but the cooler. The cooler is acting as a coolant agent. The cooled gas is moving towards the fractional distillation column, like we are already discussed about the previous class. That is nothing but the fractional distillation setup. Again, that instrument, the cylinder type instrument we are using here, and our getting our desired product here. And the heavy oil, the heavy oil also here we are not using that one, and we are applying another one method called cracking. The next topic is, that is our topic, we have the cracking. By applying the cracking method, again we are getting also gasoline. The gasoline is nothing but our petrol, you don't forget that one. So the United and UK countries, USA, they called petrol as a gasoline. So in our Asian countries we called as a petrol. So because of that reason, the kerosene or petrol we are measuring in the gallons or barrels. Gallons nothing but a gasoline. For easily understanding, this diagram will help you about the Fischer-Tropsch process. Okay, I hope you understand about the two methods. One is industrial refinery process of crude oil, and the second method of is nothing but the Fischer-Tropsch process. I hope these two methods will help you to understand the synthesis of petrol. Thank you. We will meet again in next session. For more information, kindly you can reference these textbooks or reference books I am given to you. You can look into this. Thank you.